Hello everyone, it's Sean. Welcome back to the channel. DD Audio D4.200 car amplifier, sub amplifier. This is a, if I'm not mistaken, appears to be a 4-channel amplifier, I believe, rated for 800 watts. I'm not sure if that's peak or RMS. I don't have a whole lot of technical data on this. Provided by a customer. This is a local customer who uses this amp as his test amp, and this individual's really big in the motorcycle car stereo amplifier scene here local to me, and mentioned that, well, he had this plugged in, tied to like 13.1 volt or 2 volt or something, and decided to cut out on him just like that, and not a pleasant smell. I'm going to go ahead and just be honest. I'm hoping it might just be a cap issue, maybe some MOSFETs on the power supply side. This is a pretty beefy amp. It feels well built. I'll put it that way. It's very heavy, so I imagine the heat sink in this chassis and everything is probably adding to a lot of the weight. And a good beefy heat sink, I suspect Class D amplifier is typically a relatively good sign of a amp that's built to last, because you want to dissipate heat waste from whatever you're using to amplify your signal to regulate. Anyways, or develop voltages, that too. But anyways, yeah, let me get this apart and check out the inside, and maybe something apparent will come to us as far as why it smells of, yeah, it just stinks. All right, let's get it apart. Okay, I got this torn down as much as I feel like I need to. And, well, first off, I want to talk about some things that I like, okay? Flip this over for a second. Now, by design on the front, so we got power input, rectification. We're basically going to take the DC, turn it into an AC, and then regulate voltages from there, higher DC voltages, I believe. Essentially a typical design in most of these Class D amplifiers. The things I like, well, first off, Nichicon branded caps. Now, Nichicons are just one of good name brand reliable capacitors. I like in the capacitors we have over here that they appear to be rated for 105 degrees Celsius, so they are high temp capacitors given the environment they're in. That's always nice to see, that these are not just some general purpose electrolytics sitting in here, that they've done their due diligence and put in 105 degrees Celsius higher temp capacitors. Okay, so I'm really glad to see that. I'm really glad to see Nichicon capacitors. Okay, as far as I can tell, just from the design on the upper end, not really seeing any parts that I think are going to be hard to source. I don't see, well, it's hard to kind of tell underneath this light because they've got a conformal coating over a lot of these parts, like this one right here, and these over here, but you can still make out the part number in it, so I'm not seeing parts that are obfuscated or sanded down, at least not from an initial glance. That makes me very happy to see that. So push comes to shove, should be able to source pretty much everything on here. Little inductors here at the very end. Don't know the value of a lot of these components. Are all SMD. Don't know the design. Let's see, we got some optocouplers and stuff in here as well. So no obfuscation on many of these components on this side. Everything appears to have a part stamped, number stamped on it. And even if those parts aren't made anymore, just having a part number that's stamped on it will allow me to source a suitable replacement. However, I doubt that's going to be an issue with this. So far, that can come back to bite me. All right, now looking on the bottom side, we have, we got, mains DC coming in our ground. We have a lot of components sitting in here. I don't know if these are MOSFET style for voltage regulation or voltage regulators, or just like Darlington transistors. I don't really know what these 3-pin integrated circuits are, semiconductors, whatever. I don't know what they are yet, not till I lift them up and look at them. But everything, even on the bottom side, is heat sunk, okay, including the, everything has a pad on it, to provide, isolation between either the base or the collector or emitter or the gate or whatever it is. On the back plane, usually that's connected to the center pin. So that way, you'll have it'll be fully insulated and isolated from the chassis, and then enough heat sink compound in order for to incur heat transfer. So I like the design a lot. I think they've done their due diligence in this design, and I'm not seeing any parts that are sanded or whatnot. Now, as far as the smell goes, the smell's a different story. Yeah, we've had an electrical failure in here, and like he said, it doesn't power up, and I didn't see the sense of me powering up, having, had a whiff of what it smelled like when he gave it to me. It basically happened the same day the guy reached out to me and asked me if I wanted to repair some more things. But now that I have it off and I'm done a visual inspection, well, we can see an issue right here on whatever semiconductor that is. As a matter of fact, if I zoom in, can you see it as well? I mean, the whole leads down here they're black. They're burned up. And the smell is in this general area. Oddly enough, it smells a little bit stronger over here than it does over here. But let's just pry it up a bit. Yeah. Oh, yeah. Oh, yeah. Yeah, there you go. So much carnage. And unidentifiable now. I also spoke too soon. That part has had its face scrubbed off. This part has had its face scrubbed off. Kind of can read a little bit of numbers in there. Maybe I can figure out what that is. We can clearly see RF 1405 here, so that's going to be a MOSFET. This one has some kind of shmoo on it. Maybe I can clean that off and get a part number. And this one as well. So I might be able to reverse engineer this. Not too sure, but we can see right there a definitively failed component. Okay, let's discuss a little bit findings here. Go over what I believe the parts will be, and find a common way of, hopefully a logical way of confirming what I believe these parts are. Okay, so after scrubbing a little bit of isopropyl alcohol, these last three, they're all IRF 1405s. Marked on the board is Q38, Q42, Q42 alpha. Here goes one thing that we'll see as an indicator. Silk screening on the PCB. Okay, with our 3 unmarked ones where they've been obfuscated, I'll cut this one out. We have on the board Q36, Q34, and Q34 alpha. To clean that up and get some conformal coating because that one detonated seriously. Okay. Now, what are some other things that we can say? Well, I think, how do I put this? Well, on the opposite side of the board, we have 2 toroidal transformers. Pretty common in switch mode power supplies. Okay. Now, this one right here feeds is in path of these 6 TO220 3-pin MOSFETs. Zoom in channel, I think. When we look at each one, okay, and I start looking at the pinout, the leftmost pin, each one of these, goes through board, and on the other side there's a 100 ohm resistor. Okay. Center pin of the first 3 and the second 3 are all electrically connected through via or trace. So there's continuity between those pins. And they all also touch, these legs on our toroidal transformer, essentially, that are here. And if you're to round, we're talking about these 1, 2, it's like maybe 4 legs. And let's see, 1, 2, 3, 4 there. So 1, 2, 4. Yeah, essentially 3 legs over here. Okay. But the 4th leg being directly tied to our 12-volt source, even if not directly touching these MOSFETs. Okay. And it appears these 3 are driving that leg on the toroidal. And if I was to lift this up, these 3 center tied to this leg of the toroidal, and then this leg right here is going to, looks like it's touching this little thermal IC here. I can't remember any of these devices, but essentially, there to detect ambient temperature and provide a degree of protection. Okay, I think like an NTC or something. I can't remember what they're called off the top of my head. All right, so the pin 1, or leftmost pin, tied to basically 100 ohm resistor. Center pins tied together. Now, all 6, the rightmost pins, they're all on the same plane PCB. So they're all in continuity together. All right. So what this does is this suggests a parallel MOSFET topology. Okay. Which is pretty common in high power switch mode push-pull switch mode power supplies in a push-pull topology. Then look into the other side. Got some more devices, but do I want to talk about that just yet? No, not just yet. I will say it is extremely uncommon for a design to mix MOSFETs and diodes under all Q labels in the switch mode power supply. Rectifiers would typically be marked with a D, like D12, D34, or CR, not Q. Although we do have rectifiers sitting over here. Not seeing the markings yet. Most likely those might be a D. Yeah, I'll have to keep looking. But I'm not seeing the silk screen on the board. It's probably hidden underneath some of this heat seeking compound. So strictly based off of the label grouping and design norms, I would believe that these first three obfuscated sanded off MOSFETs are also IRF 1405s or equivalent in channel MOSFETs. You're looking at a high current switch mode power supply with a 3+3 MOSFET for higher power output and better heat distribution, essentially, which is a really good, common design. Now, the leftmost pin that's, going through board tied to the 100 ohm resistor is typical for gate drive input, left pin typically being the gate. Center pin, the drain. Center pins are connected together at the drain. And in the Q34X series and Q38X grouping as well, also being tied to the 12-volt rail. And then the right pin, all 6 pins are connected. This is typically the source. I'll have to look up the part number, but we're basically going gate, drain, source, which is pretty typical. Left being pin 1, gate, pin 2, center, drain, source. And with all 6 pins connected, this is source going to ground, or probably a transformer or something along those lines. Okay. I have to go back through and look again. Really, my only concern is with the marking on these first 3, because you have a dot at the bottom of the TO22 package towards the legs, and with these latter 3, the dot is up towards the top to still centered, but towards where the screw, if you had a screw that'll hold it in place, is located. Okay. Now I realize I'm doing a lot of bitting. I'm going to be replacing all of these, regardless of what's failed. Okay. We can see a failure there. I can desolder them all. We can test them all. And for serviceability of the customer, I'm going to replace all 6. That, and it'll keep everything uniformed and just make it easier in case somebody else has to go back into here. Now, why the dot is throwing me off is because typically, the dots can be an indication of slight variations within these components. Okay, so like maybe the leads are reversed. Okay, on 3, which you can see that. As a matter of fact, when we're over here at our MUR 220 or 2020 CT and MUR 2020 CTR, has an indicator by the nomenclature on it, the 2020 CT being a dual common cathode configuration rectifier. Okay, diodes, 2 diodes with a common cathode, and then the CTR being very similar in design but common anode at the center versus cathode. Okay, And so by design of a TO220 package, which all these are, if I'm not thinking things incorrectly, being a little late at night, you know, a dot or a marking or something could represent something different at the leads, is essentially what I'm saying. Okay. But I don't think so in this case. I think that, along with the scrubbing of this stuff off, is there to kind of throw you off, or throw off a technician to thinking that something different is occurring with this, three MOSFETs sitting right here. Okay, I think it's a game. I think it's probably an alternate manufacturer, wherein the dots were just imprinted on it in a different fashion. And then, of course, they obfuscated it by sanding it. And so that adds to the confusion of, oh, what part is it? Because the dots don't match up and we don't have a part number and all that kind of stuff. And then, you know, the 12-volt input essentially going to what I believe would be the center tap of the toroidal. This grouping going to another leg. This grouping going to another leg. Left and right of what I believe is center tap. I think that pretty much seals the deal. And if it didn't seal the deal, well, we have on the other side, okay, the other toroidal sitting here with a MUR 220 CTR and MUR 220 CT at the secondary, I believe, of the toroidal transformer. I haven't looked to see what's physically connected at the center tap, but I'm going to assume possibly the 12-volt input as well. And yeah, looking on the back, see 12 volts going to this lead there. And we got these other taps going to center, and this tap going to center. Okay, so with this design as well, look, the last two taps on the secondary going to those rectifiers. But so we got the same type of rectifiers in here, and if I just look down the line at all these TO220 packaged semiconductors, every single one of them is marked IRF 1405. And how many are there? Well, let's count together. 1, 2, 3, 4, 5, 6 before we get to the rectifiers. So here's what we're going to do. This is a power supply issue. Doesn't power up. Probably pulled a lot of current. Heavy smell. I don't know if the outputs are bad yet, but we do know that the input doesn't work. And so what I would like to do is I'm just going to put a bunch of 1405s on order. Maybe those MUR 2020 CTs and CTRs. Just get everything replaced within the switch mode power supply section. And then from that point, we'll power it up and we'll see what happens. Now, there is something, maybe this is just a small gripe, but it is something I'd like to highlight for you as well. Because all these in-channel MOSFETs were, the legs of them, or leads, were bent at a 90 degrees, so that way that one just broke and broke off, and I'll show you the reason, one of the reasons why, other than just me pulling up. But they were all bent at a hard 90 degree bend, and so that way the tops could lay flush on the board. And I believe this is a mistake in the manufacturing process. Okay, let me get my let's bring this over. Okay, I'll bring this up for a second. I just want to show y'all things. So there goes one that I've cut out. Here goes the one that broke. Okay, now mind you, I only bent these upwards. We're kind of conformal coating glued place, which didn't help. But look at how weak bending them up they were, that 90-degree bend point. Okay, now if I go down the line, this almost appears like a cold solder joint. That's actually a lot of weakness right there at the 90-degree bend. Same thing here. See where just with me bending it upwards has caused the legs to basically start to break. This one I bent upwards, and it did something that I would hope and expect to see. The leads themselves just kind of, that's a good angle. Kind of do this angle here. Okay, you can kind of see it off of this first lead right here. Instead of them breaking where the 90-degree bend is, you can see that they bowed upwards. Okay, that's what I would expect to see, and you can kind of see why. Well, maybe the conformal coating wasn't as strong right here, but what I think occurred is that we didn't have super strong prominent 90-degree bends on that MOSFET sitting there, and see that this one suffering that same fate right here where it's starting to break. Okay, so I'm going to show you, when I replace these, a method that will prevent that. Now, hold on a second. Okay, when you're mounting devices like this through hole, okay, and you have to bend them, you do indeed want a 90-degree bend. Okay, same thing when if you're doing through hole resistor, right? Here goes carbon composite resistor. Okay, we'll call this the resistor, and on both sides the legs or leads coming out, and you would make a 90-degree bend, and then you could put them, each leg through hole. Okay, but there is a point when you're trying to make that 90-degree bend super acute. That's not the right word, because it's 90 degrees, 90 degrees. When you're, I guess, pinching the corner, making it too crisp, that you actually cause a failure where you're bending it because you've overstressed the lead. Okay, you've caused it to crack in the center, and that's not good either. Not good for the sake of the component, because guess what? Current has to carry through the lead. And when you take a lead that is at a certain width, a certain depth, capable of carrying current, and you start to put fractures in it because of how crisp or tight that 90 is, you're actually doing more damage. Then maybe you start getting arcing as it heats up, and those cracks become prominent, and maybe current's not able to flow as well because you've impeded it by reducing the basically how much contact the electrical resistance in the lead itself increases because you don't have as much surface area connected because of micro cracks or fissures or something. At least that's how it goes in my head. So yeah, you want 90-degree bends, but you want them to be more on the rounded side than up and straight, because in here at that bend, that's where you create issues. Okay, you're basically forcing two metals on top of each other and they're going to split. So you want a 90-degree bend, but you want it to be less pronounced, I guess, more rounded. Okay, and that is acceptable. But how we'll replace these is, probably best for me to just demonstrate it. I'm going to demonstrate to you my methodology. We're getting these flat and the leads through the PCB soldered in place. That I believe would be less stressful on the legs themselves, and less of an issue concerning the overall electrical connections to our in-channel MOSFETs. Okay, let me get these parts on order, and once they get in, we begin some work. Parts are in. Time to get busy. For the IRF 1405s, I have part number IRF 1405, Papa Bravo Foxtrot. That's coming through for you. For the MUR 2020 CT, replacement part number we will use if we need to use it. I'll be testing these after I remove it. Is part number BS Victor Sierra TAC MUR 2020 CT. TAC M3 should be a substitute for it. And let me just come in a little bit more. All right, there we go. And for the MUR 2020 CTR, we got one that's double anode, one's double cathode, whatever, center cathode, center anode, whatever. But for the CTR, we will use a MUR 2020 RG, or Romeo Golf. They don't make the R2020 CTR anymore. But or common cathode, common anode. That's what I was thinking of. But this one is the most current part number for the CTR. Again, well, I'll test these two outside of circuit. All 6 of these will go ahead and get replaced. Obviously, I'll have to do a little repair right here to our PCB, mask off this area where that one. Okay, so let me get these, get all these out, and we'll get them tested, and I'll come back and show you how I'll prevent failure within the legs of these going into the future. Now that I have this amp, the pads cleaned up a bit, and our new MOSFETs inserted, I notice I don't have any of them soldered in place. Okay, because I want to show you what I would do to relieve some of that stress of having a crisp 90-degree bend. That's creating the failure point. Probably, maybe it's not the bend that's creating that weakness. Obviously when I pulled it up, that also caused it to crack. But these things do get hot, and that repetitive heating and cooling cycle can also cause them to crack. Okay. And then break, and then you get an increase in current, and then that causes a failure. Okay, so what we'll do to try to prevent that is have a nice sloped entry. And how I'm going to do that is basically just lift up this. I don't want a lot of pinching pressure, although I do want this to kind of socket in place pretty good. So what I'm going to do is I'm just going to fold these over within the area on top of the PCB in which it would have set if it happened to have been a hard right angle 90-degree bend. So from that point, once that's in there, I'll just come through on the back side, the tad bit of flux, and I'm not looking to necessarily perfectly solder all the pins right now. I'm just looking to kind of get them a tad bit tacked in place. We'll put it that way, so that way it's not really moving too much. So got a little bit of solder. All right, so I've gotten one pin tacked in place. That should be good enough. All right, so from this point, it's just going to be moving down the row. All right, looking to see where I can bend this over most effectively. About right there. We might need to go a little bit further down. Okay. About right there does it. Okay. Then I'll be doing the same thing for each one of these. Let me go ahead and get flux on that first pin. We'll solder my soldering iron. We just get that first one tacked in place. So that's all there is to it. I mean, obviously I'm going to trim it up on the other side once I have all of them actually soldered in correctly, but we're not making a sharp 90-degree bend at this point, which forces the metals to fissure or crack up the center. And yeah, typically you would do a 90-degree bend on components going through boards with long leads, when you're talking about potentially passive components, resistors, capacitors, maybe the leads off of diodes and stuff like that. But something like this, you don't want a whole lot of pressure where it's going through hole. Okay, you don't want to put tension where tension shouldn't be, I guess I'm trying to say. Anyways, so I'm just going to repeat this process for all 6 and get them soldered in place. And yeah, that's all there is to it. Well, if I got anything else interesting to show, I'll let you know and we'll come back. These 2 components tested good from the PCB. They tested good in the PCB as well, soldered in place. But, removal and testing is always good. The one thing that did occur when I was removing our common anode one, common cathode, I can't remember which one this one is. It's facing upside down. There's a little snubber capacitor that got freed on this pad, on 2 small pads. Here, I'll bring this smaller camera in. Right there and right there. And then the metal capped side of that small snubber cap came off, whether that was done by me or maybe excessive heat or something. But regardless, you can operate this amp and basically these voltage regulators essentially without that snubber cap. Okay, but you don't want to do it long term because that is, by design to help control like inrush current, things like that. So I got a replacement snubber cap. We're going to place it in there. This is between pins 1 and 2, and we're looking at a 0.01 microfarad 100 volt ceramic capacitor MLCC that I'll be replacing it with. You can see that part number right there. Easy peasy. Just gonna slide it into place here. Okay. And with my soldering iron, I'll go ahead and with the solder that's on there, get one side tacked in. Now that I have one side tacked in, come through, we'll get the other side with a little bit of solder. Clean it in the pad. Got it. Both sides. Now, if I wanted to, I could throw the hot air gun on this and get it seated perfectly well, but there's really no need. I'm centered on each pad. It's soldered in place. It's going to make continuity. It's there. All right, so with all my 1405s, RF 1405s replaced, with these testing good in and out of circuit, I'm going to go ahead and throw this together, and we're going to fire it up, and we're going to see how it does. Well, I've got it cleaned up and put together somewhat. Why don't we do a power up test first, and then if everything goes well, we can check the output or inject a signal and see if we have an output. All right, I'll turn on the benchtop power supply, and we will increase current limiting a bit. I'm going to get it up to 12 volts. There we go. That might be slightly too current limited, so I'm going to turn it up a bit more. I still got to turn on the REM. I'm using my signal generator to create a DC voltage for it, but let's make sure that we got the 12 volt rail on here, and we do. We're seeing 12 volts right there. Okay, so for my signal generator, I'll change the waveform from a sinusoid to a DC waveform. All right, I'm gonna just put it at 2 volts for now and just make sure we get 2 volts right there. Yeah, we're seeing 2 volts. So everything is connected pretty good. All right, before I turn it up anymore and trip the REM, I'm gonna put away my multimeter, get it a little bit out of the way. Okay, I've got to keep my eye on the current draw as I increase the DC offset voltage. Let's get it up at 6 volts. No light yet. 7, 8, 9. Now I got some life. 10. And it looks like I'm drawing 1.4 amps. It's a little low, so I'm going to turn that up. Okay, there we go. So it started current limiting, but I was able to turn it up, and we are at 1.5 amp, 1.6 amps, and 1.6 amps, and it's pretty much holding steady right there. So this is a good sign, actually. And before I start hooking up an O-scope or anything, maybe we check the output channels. There are 4 channels on this amp. I just want to see, we might have a DC offset voltage at the outputs. Shouldn't see a lot of DC. I'm not seeing anything there. What if I put this to ground? Oh, nothing. Good. So that's right now that's a pretty good sign. Let me set up the rest of my test equipment, and we'll come back and see if we get an output. All right. So as of right now, I have a 80 hertz tone, 1 volt peak to peak, plugged into channel 1. I'm going to turn that on, and well, let me go to channel 1. The first thing I'll look at is the negative rail off of channel 1, basically the return. Okay, so sometimes when you have a class D amplifier, you might get a sinusoid on that. You might have a signal on both sides. Ooh, and we definitely have need to increase the amplitude there. See, we'll take it up. I'm in, ooh, wrong way. Take it up. I'm in 10 by on my probe. Yeah, so there we go. Yeah, sometimes you'll have half of the wave on one and the other half on the other pin in Class D amplifier. Then they combine as a speaker. This one does not seem to be that way. So I could absolutely put a ground on that pin. And we can see it right there. 19.4 volts. All right, let's move over to channel 2. Just checking to see if we have an output on all of our channels. And let's see, what do we got on channel 2? I got something there. What are we getting? 19.6 there on channel 2. Let's go to channel 3. And channel 3 should be right here. 18.2 on channel 3. And let's go to channel 4. What are we getting on channel 4? And 17.8. So maybe a little bit of linearity issues there on channel 4. I don't know. There's quite a bit of adjustments, but I am definitely getting amplified audio, and this amplifier is powering up. Well, that's going to do it for this first amplifier in a string of Class D amps I got to get done right now. Yeah, so there you go. You have it. Hopefully this video was beneficial to you. We found some burnt components or blown components, MOSFETs on the switch mode power supply side of the amplifier. Those who the part numbers were rubbed off, scratched off, eroded off, whatever. And we were able to go through and hopefully paid attention to the analysis portion. You can see, and that would be beneficial for you as far as determining parts where the manufacturer scratches or rubs or braids the part number off. But ultimately, we were able to select the right replacement MOSFETs. The amp powered up, and we injected an 80 Hz tone and are getting amplified audio at the output. So as of right now, everything looks good. I'm going to clean this up a little bit more and get it back to the customer. Cool. Thank you for watching. If you enjoyed this video, please let me know by leaving a comment in the comment section or give the video a thumbs up. If you're new to this channel, I got a lot for you. You might as well subscribe. You're already here. As a matter of fact, 90% of my viewers are returning, but they're not subscribing. If you really want my channel to grow, it's not beneath me to beg you to please subscribe. All that being said, thank you for watching. Take care. And goodbye. Bark.